This section is about three different things. It is about absolute value and its expressions. It's about absolute value as distance, and it is about order of operations. So again, this is all review. You will have seen all this before, and we're just going to go over it real quick, and then you'll have time to work on your assignment so that you don't have to have any homework. Okay? Let's first talk about what absolute value expressions are, what absolute value is. So this first part is just a definition of what absolute value is. The absolute value of a real number A, so the absolute value of A, is the distance from 0 on a number line. So that's what the absolute value is all about and what it signifies. Is if you could take that number and put it on a number line, how many units away it would be. It's always non-negative, right? Because you can't ever measure a distance and get a negative distance. Okay, that when we talk about that kind of thing, we're usually talking about direction. But if I had a tape measure and I was measuring the distance from, point A to point B, it would always be a positive or a non-negative number. The reason we say non-negatives is that it can be 0. So 0 or positive is going to be an absolute value. The output value of any absolute value is always going to be non-negative. So for example, this is an example. You can write as much of this down as you think you need to. The absolute value of -5 is +5 because it's 5 units away from 0. -5 is 5 units away from 0 on a number line. Okay. Again, it generates a non-negative output. In this case, +5. Another example is +3. Okay, generates a non-negative. 3 is also 3 units away from 0. So again, my output value is non-negative or positive plus zeros. Okay. Again, you can write down as much of this as you think you need to. Here are some examples, and I want you to take a picture of this page, and we're going to talk about how to think through this a little bit to get a better idea of what you should be doing. So if you notice here, these two A and B have the same numbers, just the order of them is switched around. Okay, and what you need to do when you look at a problem like this is we're not plugging the square root of 3 in a calculator and subtracting 3. We're not doing that. Okay, what I want you to be doing is thinking through what type of value this expression inside the absolute value is equal to, whether it's positive or negative. If it's already a positive, then we know it will produce that same number. So in this case, is the square root of 3 minus 3 going to be positive or negative? And here's how you have to think through this, right? I'm not asking you to find the square root of 3, but approximate what its value might be. Okay, what is the square root of 3 going to be in between?
1 and 2.
1 and 2. Why do you say that?
Just is.
Well, I need a reason. Why? You're right. The square root of 3 is going to be in between 1 and 2, but why?
When you multiply whatever the number is, you get you 3.
What?
Whatever the number is together.
Do you just want me to tell you what you want to hear?
I would.
Because 2 times 2 is 4.
Okay. So this number has to be smaller than the square root of 4. Okay? Right? So the square root of 4 is 2. And the square root of 4 has to be bigger than this. Okay? Which means this number has to be less than 2. Which means the square root of 3 minus 3 is going to be positive or negative?
Negative.
Negative. If this number has to be less than 2, some number less than 2 minus 3, right? It's not bigger than 3. Here's the long story short. This number is not bigger than 3, and the only way this can be positive is if this number was bigger than 3. Okay? Which it's not. It's between 1 and 2. So that number, whatever it is, minus 3, is going to produce a negative. Which means the output of this has to be the opposite of it. So for example, let's think about what was on the last screen. We said the square root of -5 is +5. We changed the sign of -5. We took the opposite of -5 to get the +5. Because what's inside of here has to also have a negative value, this is going to produce a positive, which is the opposite of that. So in reality, the opposite of what's inside of here will then be positive, because the opposite of a negative is a positive. All right, well, if I have this negative out in front and I distribute it and want to get rid of the parentheses, right, I would have negative square root of 3 plus 3, because it changes both signs, which, if I rearrange it to put the negative second, is that. Since these two numbers are the same, and their order is different, that makes them opposites. Okay, think about it. Think about an example like this. All right? Numbers are the same, their values are similar, but they have opposite signs, right? When I switch the order around, the numerical part's the same, the sign on it is different. That's no different than a problem like this, except because of the fact that we don't really know what the square root of 3 is, it requires us to think a little bit. So if I had the same problem, said the absolute value of 5 minus 7, the absolute value of 7 minus 5, both outputs are positive too. So in this case, both outputs, since this is a positive, we already know 3 minus something smaller than 2 has to be positive. So then this one is going to also be 3 minus root 3. So the long story short is, and when I use an easy example like this, when the numbers are the same and it's subtraction and the order is different, the output value is still going to be the same. All right? Even though this is a negative 2 in here, it kicks out as a positive 2. This is a positive 2, it stays positive. The same thing when you have a radical expression like that. So the trick is figuring out which one of these is positive and which one on the inside and which one is negative. So there's going to be a little bit of thought that you need to put into it, and the best way to do it is using numbers that you already know. And maybe the question is this bigger, is this number here, square root of 3, bigger than 3? And if it's not, then you know you get a negative. Okay, just number sense stuff there. Okay, so that's the first kind of thing with expressions. Now let's talk about distance. We talked about absolute value as it relates to distance from 0 on a number line. Okay, how far apart two numbers are can also be, you can also use absolute value to find that value. Okay, so absolute value is also used to denote distance between 2 points on a number line, how far apart those 2 points are. So those examples that we looked at just on the previous slide are kind of our lead into this. Here's essentially what I was talking about. If you want to take a picture of this page, you can. If I have 2 points A and B, whatever those A and B represent, they're real numbers. They could be irrational, they could be rational, they could be integers, whatever. They're just two numbers. Okay? The distance can be found one of two ways. You subtract A and B inside the absolute value, or you can subtract B and A. And as I showed you on the previous slide, that value will be the same regardless of the order of A and B. Okay? And I showed you two examples on the last slide of how that was true. One with kind of a trickier radical expression, and one with some really simple natural numbers. Okay. So here's an example. If you want to take a picture of that, feel free. And then I want you to write an absolute value expression that represents that distance, and then simplify it to find out what the distance is. And I know maybe these numbers seem pretty easy, but go ahead and do it. There are two possible correct answers for this, right? I could either have 4 minus negative 1, the absolute value of that, or I could have negative 1 minus 4. Those are my two options. Be careful with subtracting a negative, right? Understand that that would also be a way to check. Either I have this, which so 4 minus negative 1 is positive 5. So the absolute value of positive 5 is 5. Negative 1 minus 4 is negative 5. Absolute value of that is positive. Okay. Either way, I get the same thing. So that's another use for absolute value, finding the distance between 2 points on a number line. Okay. How many did the top one? 4 minus negative 1. Raise your hand. How many did the bottom one? Negative 1 minus 4. Okay, see? That's cool. Whichever way you want to do is fine. Next, there's an example of how you would see it on a number line. Obviously that distance is the same. Whether you start off here or start off here, the distance is the same. Okay? Let's talk about order of operations, the last thing. Okay? And I know you've learned lots of different ways to remember the order of operations. And I've altered it a little bit so you can hopefully keep it straight. If you want to take a picture of this page, you may. And then I'll go through them real quick and give you a problem to work through. So rather than going with the PEMDAS that you've learned, I changed it to GEMDAS because it's really not just parentheses. As we talked about at the beginning of class with braces and brackets and those things, we're really talking about grouping symbols, period. And grouping symbols come in lots of different forms. They can be parentheses, they can be brackets, they can be braces. But the things that we don't often think about are absolute values are grouping symbols. A fraction bar is a grouping symbol. It separates the numerator from the denominator. You're supposed to simplify the top before you worry about the bottom. A radical is a grouping symbol. And so the key thing is you work your way from the inside out every time when there's multiple sets of grouping symbols. And parentheses just doesn't cut it for us anymore. Maybe that works when you're in elementary school and you don't have so many complicated operations and things like that. But the reality is that there's so many more symbols than parentheses. Then once you've simplified everything inside that set of grouping symbols, then we go to exponents. And then there's this problem with the idea that because it sounds better like this, multiplication is somehow more important. It's a higher level than division. And so that's another place where you see people make mistakes. They think multiplication is more important, even though division might come first when you go from left to right. This is all about left to right here. Okay? These have equal priority. Multiplication is equal to division. Addition is equal to subtraction. So you do what comes from left to right. Hopefully, this is all very familiar to you and you're good and you can apply it properly to this particular problem. So please take a picture of that and then work through it showing all your steps. The reason the rest of this slide is blank is because I will fill it line by line with the solutions, one piece at a time. Try not to skip steps. Try not to do things in the order that seems easier to you. Please follow the order of operations. Go. So our goal here is we've got to look at grouping symbols. And again, you have to go as far in as you can go. And then you have to understand that some things that don't look like parentheses, brackets, braces can be grouping symbols. So obviously here, this 7 out here. And before I get into that, one of the things in my years of teaching that I see happen all the time is kids will gravitate toward the part that seems the easiest. And so oftentimes I'll see a 12 pop out of here, even though the 4 is being multiplied. And you can't add before you multiply. And every single kid that I would ever talk to say, are you sure you're allowed to add before you multiply? And they're like, oh no, you're not allowed to do that. And they automatically see that. Or they'll want to subtract real fast because they gravitate toward the easy part. In reality, you've got to go inside as far as you can go. So I've got my braces. So now inside my braces, I see that I have a bracket. Inside my bracket, I say I have parentheses. So my focus needs to be on this 5 minus the square root of 64. Well, the square root of 64, the square root, the radical, is a grouping symbol. Okay, so I want to do this first. So when Reese was asking how am I supposed to FOIL this, he was going to go 5 minus the square root of 64, and he wanted to FOIL that out instead of just taking the square root of 64. So in one step, that's all I've done. Okay, I changed the square root of 64 to an 8. And now I'm still, this is the innermost part. So I started here, now I work myself out to the next set of grouping symbols, which are the parentheses. So 5 minus 8 is negative 3. Okay? And of course it starts getting squeezed down because I start losing symbols, I start losing numbers. Okay? And now at this place, I still have a parenthesis only because it's a negative number. Okay, that's why the parentheses are still there. So there's nothing to do inside these parentheses. So I could go to brackets, but I can't go to brackets until I look inside here and go, all right, well, after that I have to do powers, exponents. So I have to take the negative 3 squared next. Okay? And again, here are places where I will see people start doing things that they shouldn't do. I'll start seeing that 12 show up here, even though the 4 is being multiplied. I have brackets, I have parentheses, I go as far in as I can, that is a negative 7. Okay? So everything else has stayed the same. I've really only been working with inside the brackets. Inside the parentheses first, then inside the brackets. So now again, here's places where I'll see someone go 12 and then they'll go 12 times negative 7. That of course is wrong. Multiplication comes first. Right? I've got to do that. 8 minus 28. Okay, and that gives me negative 20. Look out for that sign that's there. It's negative, negative. The answer is 27. Okay. How many had it? Okay. How many see the one place that they mess up that screwed the rest of the problem up? Okay. So here's the thing that I'm going to tell you. For all of you calcoholics. When you do these problems, I need to see all this. Okay? Yep. If you don't show me your steps, you're not getting full credit. Okay? So I understand that you can type this in the calculator and it will give you the output. But I need to see the steps. I need to see that you actually know how to follow the order operations properly. I feel like that's mandatory in order to receive a diploma. Like you shouldn't be allowed to have a diploma without actually demonstrating that you know the order of operations. And that is a low level expectation, right? So let's practice this a little bit.